Hello everyone, let's start the given question. The question says that the progress of the reaction A giving n moles of B with time is presented in the given figure which is given to us. Now the question is, this is a concentration versus time graph and the question is to determine first the value of n, second the equilibrium constant K, and third the initial rate of conversion of A. So firstly let's start by finding out the value of n. Now what is the reaction which is given to us? The reaction here given to us is that A is giving n moles of B. So this is the main reaction. And if you look here, the reaction is taking place in equilibrium. There are two time period that we have to consider. So I am considering time period t is equal to 1 and t is equal to 5 hour. So that means I am considering the time interval from t1 to t2 here only, that is from 1 to 5 hours. So what will be the difference here in time? The difference here is total 4 hours. So I am considering this 4-hour bracket where the reaction is taking place. Now what do we need to do is find out firstly the decrease in the concentration of A, because A is reactant and as the reaction will proceed its concentration will decrease. So the initial concentration is how much I am taking here? I am taking here 0.5, right? 0.5 at time 1 hour, and at 5 hour it is concentration is how much? 0.3. So write down 0.5 minus 0.3. The value you will get here is equal to 0.2 molar. So this is your concentration of A. And what about B? Now B is the product here, so its concentration is increasing. So at these two time intervals, that is at 1 hour and 5 hour, B concentration is increasing from this value is how much? 0.2, and this value is how much? 0.6. So what will be the difference here? 0.6 minus 0.2, the value is coming out to be 0.4 molar, right? We are getting here two values of A, 0.2, and B is how much? 0.4 molar. Now from this what we can see that the concentration of B is 0.4 and that of A is 0.2 molar. So which means what? The concentration of B is twice the concentration of A. So that means the value of N will be how much? The value of is equal to 2, right? So the value of N is how much? It is equal to 2. So this is your first part of the question. Now what do we need to do in the second part? We need to find out the equilibrium constant K. Now for the equilibrium constant, we need to check the reaction where the equilibrium has been attained. Now if you look here, reactant A has attained equilibrium at this position because after that there is no change in the concentration is taking place. And in the reactant B, this is the time and this is the concentration for which its value is not changing. So K is equal to what? It will be equal to B equilibrium raised to the power of stoichiometry divided by A equilibrium concentration, right? So what is B equilibrium here? It is equal to 0.6. So it will be 0.6 square divided by A equilibrium concentration, which is how much? 0.3. So upon solving this, what I am going to get? I am going to get K equilibrium value and it is coming out to be 1.2 molar. So this is your K equilibrium value and this is your second part question. Now in the third part I have to find out what? I have to find out the initial rate of conversion of A. So what is the initial rate of conversion of A? So the change in the concentration of A that I need to find out for 1 hour period. So for 1 hour period, what is the change in concentration of A taking place? So for 1 hour period, A's concentration is from how much? 0.1 I'm taking and 0.3, 0.6. We can take any two values. So I'm taking the value for 1 hour change value. I'm going to take 0.6, which is here. The initial value I'm taking 0.6 and I'm taking then the next value which is equal to 0.5, right? We have to take the initial value change. So 0.6 minus 0.5 divided by what is the time interval I'm taking? Only for 1 hour. So divided by 1. This value will come out to be how much? 0.1 moles per. This will be mole inverse R inverse, right? Because it is what? Mole inverse and R inverse. The time period here is for 1 hour. So this is your answer to the question. Thank you.
Hello students, welcome to DoubtNut. Let us look at the question that has been given to us. So the question here says that when 0.15 mole of carbon monoxide taken in a 2.5 liters flask is maintained at 750 Kelvin along with a catalyst, the following reaction takes place. And we have been given a reaction here where CO2 is combining with 2 moles of H2 to produce methanol. Hydrogen is introduced until the total pressure of the system is 8.5 atm at equilibrium and 0.08 mole of methanol is formed. Now we have to calculate Kp and Kc for the same. Okay, so let us find out one by one. So first of all, we'll try and write out the reaction. So reaction is when carbon monoxide is made to react with 2 moles of H2, we get methanol, right? Now, at T equals 0, okay, the number of moles of carbon monoxide is given, that is 0.15, right? And let us assume that X moles of H2 was needed, right? And nothing of methanol is formed. Now, at equilibrium, okay, I can say if Y moles of, let us assume, if Y moles of methanol has been formed, then X minus 2Y moles of hydrogen must have been used and 0.15 minus of Y moles of carbon monoxide must have been used, right? Now in the question itself it is given that we have 0.08 moles of methanol that has been formed, right? Here it is given. So I can simply calculate the number of moles of carbon monoxide at equilibrium. That will be 0.15 minus of 0.08, which will be equal to 0.07, right? And number of moles of hydrogen can be calculated as X minus 2 into 0.08, which will be X minus 1.6, right? Now the total number of moles in this entire reaction can be calculated as NT at equilibrium. So it will be 0.07 plus of 0.08 plus of X and minus of 1.6. So this will be equal to a sum total of X minus 0.1, right? Actually it will be 0.01. Okay. Yes. So this much amount of moles is now present. Now to find out the value of X, we will use the ideal gas equation. So it is PV equals nRT, right? And NT we will calculate from this particular equation, which will be equal to PV upon RT. So pressure is given, that is nothing but 8.5 atm, and the volume is also given, that is 2.5 liters, and we also have R, so 0.0821 into temperature is 750, right, Kelvin. And if you just solve this, if you just do the maths, we will get the value of 0.345 moles, right? So this is the NT that we calculated using the ideal gas equation. So we can now find out X by equating. So it will be now X minus 0.01 equals 0.345, right? And this will be now equal to X equals 0.355, right? 355. Okay. Now we can easily find out the number of moles of hydrogen, right? So that will be equal to 0.355 minus, so this is X minus 0.16, right? And this will be equal to 0.195, right? Now we have everything. Now we can easily find out the value of Kc. So the value for Kc can be calculated using the concentration of product, that is CH3OH, upon the concentration of reactant, that is H2 to the power 2 into carbon monoxide concentration. And this will be equal to 0.08 upon the volume, which is 2.5, upon we have 0.07 number of moles of hydrogen upon 2.5 to the power 2 into we have 0.195, right, upon we have 2.5, right? And if you just solve this up, we'll get a value of 187.8 mole liter square per mole square, right? So this is something that we got. The value of Kc we have already calculated. Now let us go for the value for Kp. So Kp, as we all know, we have a relation between Kp and Kc. So Kp is equal to Kc into RT delta N. Now what is delta N now? So let us find out delta N now. So delta N is nothing but number of moles of product minus number of moles of reactant. So number of moles of product we have 1, number of moles of reactant we have 3, right? So it will be minus 2. So for this we need to find out the number of moles and number of reactants. We need to find out from the equation that is given in the question itself, right? Now let us put the value. So 187.8 into R is 0.0821 and temperature is 750 and this is whole to the power minus 2, right? And if we just solve this up, the value that we get will be equal to 0.05 atm, right? So this is the Kp and Kc for this particular question. Now moving ahead, the second part of the question is telling us that the final pressure, find out the final pressure if the same amount of CO and H2 is used as before, and with no catalyst, so that the reaction does not take place. Does not take place, yes. So we have to use the catalyst. We don't have to use the catalyst. So we have to use, so for the B part, the NT will be Ni initial for CO that was given in the question, plus we have to use the same amount of hydrogen also. So it will be 0.15 plus 0.15, which will be equal to 0.30. Right? Now we can find out the pressure. So pressure will be equal to NT RT upon V. So this will be equal to NT, we have 0.30, 0.0821 and temperature is 750 Kelvin and volume is 2.5 liters. And if we just do the maths, the calculation, after calculation we get the pressure as 4.926 atm, right? So this is the required solution for this particular question. I hope you all understand. Thank you.